I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. Let me thank all the subscribers and the viewers to watch my videos and post brilliant questions. This is one of the questions posted from one of our subscribers. I changed some numbers uh, so that it gives them some time to do their own calculations. The idea here is to solve a difficult exponential equation. Now, sometimes, when an equation is given to us, we are not able to follow the standard methods. And in that case, what do we do? That is what we are going to learn in this particular video. The question is right before you. We need to solve the equation which is 2 to the power of x plus 3 times 3 to the power of x plus 4 minus 12 equals to 0. We need to write answer to three significant values. Now, how do we solve this? So we have base to the base 2 and we have a base of 3. And if you try to work with this equation, it is very difficult to use these standard ways and solve. And therefore, I took this question up, and also I want to share with you another very important technique of solving some difficult questions. So I'm just naming this as systematic approach for approximation. Well, clearly the answer is also not exact value. We're looking for something to three significant figures, right? So uh, in that case, why not adopt the approximation methods which we have learned? So I'm going to adopt one of the very popular approximation method to solve this exponential equation. So first thing first, let me rewrite this equation, which is 2 to the power of x plus 3 times 3 to the power of x plus 4. It really means that this 3, when you multiply, the power gets added by 1. So I could write this as 3 to the power of x plus 5. So my equation is 2 to the power of x plus 3 to the power of x plus 5 minus 12 equals to 0. So we are basically looking for zeros, right? Now, exponential function is something which is, let me explain here and then we will look into the solution, right? So exponential function is something which is like increasing. In this case, we do have a base which is greater than 1, right? So base is greater than 1, so we have an increasing function. Now, when we say equal to 0, it really means that if I'm sketching it on a graph, then it is definitely going to cross the graph at some point. And this is the point which we are looking for. So that is of this solution, right? So we're looking for this particular point, which is our solution. Now, how do we approach to get a value at this point? One method is that we can look for a value which could give us a positive value, right? So we look for a value of x, let us say equals to a, and let's say x equals to a gives us a positive value. Then we are looking for a value of x equals to b, which gives us a negative value. So once we get these two values, a and b, then we know that the solution is somewhere between a and b, correct? So we know that now the solution is where? So we know that the solution is somewhere where the x value is greater than b but less than a. Correct. So the idea here is once we get the value as a positive value, another value gives negative, in between there has to be a zero. Since the function is always increasing, right? This function is always increasing, right? So there has to be one point where it is going to cross the x-axis, and that is the point we're looking for. So what we can do now is try a value which is somewhere midway between these two. Let's say we can try a value here, right? C. Now, if C is negative, we can try a value which is increasing more than C, right? So that we can try a value here and then ultimately try a value there. and then we can converge to solution. You get the idea. So like this, with some trials, we can actually converge to a very accurate value. You get the idea. So this is the concept which we are going to use to solve the question. Now let's look into the solution itself. So what I've done here is, you have understood what the strategy is. So once again, the question here is 2 to the power of x plus 3 times 3 to the power of x plus 4 minus 12 equals to 0. We need to write our answer to three significant figures. Well, many times we say three significant figures, right? Not values, but figures. Okay, one and the same thing. Now, systematic approach which I have discussed with you will be followed. That is to say, we'll try to find the value which gives us a positive value for the function and another value which is negative value. Then somewhere midway between them we'll try and keep trying. So that is the whole concept. So first thing first, we have rewritten the equation in the form of 2 to the power of x plus 3 to the power of x plus 5 minus 12 equals to 0. So let's make a table with x values and then calculate the value for 2 to the power of x plus 3 to the power of x plus 5 minus 12. So let's take a simple value like 0. So substituting 0 for x, we get a value which is 232. Just use your calculator, calculate this out. Well, this is positive, correct? So we know that the graph is kind of like this, right? Increasing. So we have hit a point which is positive. That means we're somewhere here, right? So that value is 232. So we have to take a value which is lesser than 0, right? So let's look lesser than 0. Then we took minus 1. It is still positive. Well, so that means we have reached somewhere here now, correct? So with this positive value, we have reached somewhere here. Okay. Now let's take another value which is minus 2. With minus 2, it is still positive. Well, so that means we have come closer, but still not at 0. Now we took the value, which is minus 3. Minus 3 gives me minus 2.88. So that means I have reached a point which is on the other side. So now we have a negative value. So in between these two values, we have our solution. You get the idea, right? So in between these two values, we have our solution. That is the key. So we need to check for values between minus 3 and minus 2. Okay, so good point is to take a value midway, which is minus 2.5. So I substituted minus 2.5 for x and calculated. It gave me a positive value. So I'm still on the right side of my solution. So I have to take a value which is less than this. So it seems, let's go down. So minus 2.7, I tried with minus 2.7, I still get slightly positive value. That means slightly on the left side. I tried to the value of minus 2.75, and that gives me 0.0066, right? Negative, but still it is very, very close to 0. So I can do two decimal places. This is a 0, right? Therefore, we have the solution which is x equals to minus 2.75. So I'd like you to focus on the approach itself. So when we have 2 points, we're trying to take a value which is midway between them and checking whether we get a positive answer or negative. We know that the function is increasing, so if you get a positive answer, you have to try the next value which is on the left side. But if you get the negative answer, you have to try the value which is on the right side. And this systematic trial gives you fairly accurate answer, as you can see in this particular case. I hope that helps, and this is widely used practice for very difficult challenge questions. So without any formulas, we have solved the question in a way graphically. I hope you understand and appreciate it. Thanks for your time and all the best.